Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to find function values for exponential growth functions and how to find function values for exponential decay functions. How are we learning it? Through the exponential growth and decay notes and the exponential growth and decay assignment. When can we use this information? To calculate the amount of money in a savings account, including interest. How do we know we learned it? By getting a score of 4 on the exponential growth and decay assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the exponential growth and decay notes, and then I'll give you time to complete the exponential growth and decay assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the exponential function study guide and any incomplete assignments that you may have. Let's take a look now at the exponential growth and decay notes. Our notes begin with the learning goals and success criteria. Now, what is exponential growth? Exponential growth is a function where a quantity increases by the same rate in each time period. For an example, money in a savings account. So I put money into my savings account, my money increases with interest, and it goes up exponentially. Now, what is exponential growth formula? The exponential growth formula is f of x, or y, is equal to a times 1 plus r to the x power. So a is our starting amount. That's how much we start with. If we were talking about money in a bank account, that's how much money we put into the account. R is the rate of change, meaning how much interest are we gaining. X is the amount of time. So let's say it goes monthly and we're doing it over 12 months. 12 months would be my X. Now notice the value inside the parentheses will always be greater than 1 with exponential growth because I'm adding 1 plus some number. It doesn't matter what number that is, it won't be negative. So we know it'll always be greater than 1. So let's look at exponential decay now. Now, exponential decay is a function where a quantity decreases by the same rate in each time period. An example of this would be radioactive decay of a fossil. So when something dies, it eventually becomes just bones, right? We know this through archaeology. It becomes just bones. And what happens is there's a certain amount of carbon in that bone. After a while, the carbon starts to decay. It starts to wither away. It starts to evaporate. From there, we can tell how old the fossil is based on the amount of carbon that's still left. So that's radioactive decay of a fossil. Now, exponential decay, the formula looks like this. F of x equals a times 1 minus r to the x. So it's the same as growth, except this is minus r instead of plus r. A is still the starting amount. That's how much we start with. So if we were talking money that we owed, well, that might be A, right? So that's our starting amount, how much we owe. R is the rate of change. How much are we paying each month? X is the amount of time. So let's say we're paying it off in 12 months. And then notice the value inside the parentheses will always be less than 1 because it's 1 minus some value. And we know that R is never going to be negative. So it's 1 minus some value, so that means it's going to be something less than 1. Now, how can we recognize growth versus decay in graphs? Well, growth is always going to go up. Decay will always go down. So, exponential growth goes up. Exponential decay goes down. How do we recognize it from equations? Well, exponential growth equations always have a base value greater than 1. So, it could look like this. Y equals 3 times 1 plus 0.4 to the x. So obviously that's greater than 1 when we add those together. Or it could be something like this where they already added it together for you, where it's y equals 3 times 1.04 to the x, which obviously this number is greater than 1. So that's growth. Decay always is less than 1 inside the parentheses. So we have something like this, y equals 1 minus 0.4 to the x. Or they might have already done it for us and had y equals 3 times 0.06 to the x, which both of these we can tell are going to, when we simplify them, are going to be less than 1. So that's decay. So how can we tell? Let's look at an example. We have f of x equals 1/2 to the x. Well, 1/2 is less than 1, so that is decay. We have 3/2 x. Well, that's bigger than 1, right? Because that's 1.5, so that's growth. 7/8. Well, that's smaller than 1, so that's decay. 4/3, again, that's bigger than 1, so that's growth. And 1/3 is less than 1, so that is decay. Notice it didn't matter that they put a coefficient. It didn't matter that they messed with the exponents. This is the only number that matters. If it's bigger than 1, it's growth. If it's smaller than 1, it's decay. Let's look at a word problem for exponential growth. It says the population of Chicago in 2016 was estimated to be 35,000 people with the annual rate of increase of 24%. What is the population in 2019? So first of all, we're going to go ahead and use our formula of f of x equals a times 1 plus r to the x. And we're going to plug in the starting amount. Well, what did it start out at? Well, it started out at 35,000, so that goes in for a. So this is f of x equals 35,000 times 1 plus r to the x. Then we're going to plug in our rate of change. Well, we can see that it changes by 24%. Well, 24% we need to write as a decimal. So this is really 24.0%, right? So we're going to move the decimal back 2 places. 1, 2. So it should change to be 0.24. And then lastly, we're going to plug in the amount of time. And the amount of time between 2016 and 2019 is 3 years. So this is f of x equals 35,000 times 1 plus 0.24 to the third power. We'll solve that using a calculator. And when we do that, we end up with 66,731.84 people. So that should be the population of Chicago in 2019. Let's look at another example. So it says we opened up a bank account 4 years ago with $300. You have a 7% interest rate on your account. How much money do you have now? So again, we're going to start with our exponential growth formula. So we're going to plug in the starting amount. Our starting amount was $300. So we plug that in for A. Then we're going to plug in our rate of change for R. It says we're going up by 7%. So that's, we move the decimal back 2 places. So that's 0.07 is our rate of change. And then we're going to go by the amount of time. We're going to plug that in. The amount of time was 4 years. So we plug 4 in for X. And then we solve using a calculator. And when we do that, we end up with $393.24. Now let's look at exponential decay. So this time the population in Chicago was decreasing by 24%. So we start here with our equation of a times 1 minus r to the x. We know it's minus because we're decreasing. And we're going to plug in the starting amount. The starting amount was 35,000, and that goes in for A. Then we plug in our rate of change. Our rate of change is 24%, so we're going to move the decimal back 2 places. 1, 2. So that's 0.24. And then we plug in our amount of time. The amount of time is from 2016 to 2019. That's 3 years. And then I solve using a calculator, and I get 15,364.16 people. Let's look at one more exponential decay word problem. So it says you opened up a bank loan 4 years ago with $300. You pay 7% of the remaining balance each year. How much money do you owe now? So again, it's decay because the amount of money we owe is going down. So we start with f of x equals a times 1 minus r to the x. So the first thing we do is plug in our starting amount. Our starting amount is $300, so that goes in for A. And we're making payments, so we're going to plug in our rate of change. We're paying 7% each time, so it's 7. We're going to move the decimal back 2 places, so 1, 2, so that's 0.07. Lastly, we're going to plug in the amount of time. The amount of time is 4 years, so that's 4. We plug that into our calculator, and we get that now we owe $224.42. There's a video here that shows you how to check exponential functions in Desmos, so you can go ahead and watch that video as well. Let's talk now about how we can use Desmos to check our work when dealing with exponential functions. So we'll go here to desmos.com, and we're going to click on Graphing Calculator. And it should take us to a page that looks like this, right here is where we can enter the equation for our exponential function. So let's go ahead and do that. So let's say it was y equals 2 to the x. Well, as we can see, it graphs it for us. It shows us what the curve looks like. And we can enter any equation in here. Let's say we had y equals 1/2 to the x minus 5 power. Well, now it has our new equation with our curve going down, and it is half as steep, right? And we can see that it's slid over to the right. So we can graph any equation using Desmos and check our work so that we can see exactly what the graph of the line should look like. So that's how you can use Desmos to check your work when dealing with exponential functions. Let's take a look now at the exponential growth and decay assignment. If you notice, our assignment here begins with our learning goals and success criteria. If we scroll down, we get to the beginning of our questions. So the first one says, does the following equation represent exponential growth or decay? Well, remember, in order for it to be growth, the part inside the parentheses has to add up to be more than 1. So in order for it to be decay, it has to be less than 1. So if we take 1 plus 0.2, we get 1.2, which is greater than 1. So that is exponential growth. Let's continue to scroll down. Now for this one, we want a graph. We want to pick out which graph could represent this. Well, we get 8 times 1 plus 0.34 to the x. So we know it's going to be growth, so it's got to go up. So it can't be this one, can't be this one. It's got to be one of these two. Now, notice there's no constant, so it shouldn't have any kind of a shift up or down. So this one has a shift up, so this can't be it, so it's got to be this one. So we'll continue to go through and answer these questions. Once you get to the end, you'll go ahead and click Next. This will send you to your Before You Go. Once you've completed your Before You Go, you can submit your work on Google Classroom.